Thank you very much, Sherman. So, hello everyone. I'm Brett Morgan. I work on the Flutter and Dart developer relations team. I'm based here in Sydney, and I'm here this afternoon to talk to you, or this morning, depending on your time zone, about using Dart in a bunch of different places. I'm going to be showing you some Cloud Run. I'm going to be showing you the gRPC library as a way of creating an API and then using that from Flutter. So it looks like I need to click on the window. So yes, using Dart on the server and the client. So what am I going to cover today? I'm going to talk about running Dart on the server, have a look at Google's Cloud Run service, introduce you to the concept of gRPC as a way of easily building APIs, and then I'm going to show you how to use gRPC in Flutter easily. What do I do as a day job, and how does it play into this? Well, there's this little service that you may have heard of called Dartpad. It allows you to type some Flutter code or some Dart code, press run, and have it work in your browser. I'm actually responsible for the compilation backend of this service, and it's, strangely enough, all Dart, and as of a couple of months ago, it all runs on Cloud Run. Before that, it used to run on App Engine Flex. So, how do you get started with Dart on the server? So the easiest way to get started with Dart on a server is to activate a package called stagehand. And stagehand is a way of generating templated Dart packages, or be it a command line application or a server application, that sort of thing. We'll make a directory and then have stagehand build us an application. So let's just escape out for a second and drag in a window. You'll get some code that looks roughly like this. This is not quite exactly what you get right now. This is sort of stagehand from the future. This is me making it null safe. I'm not sure if there's any changes here on this specific screen, but this is what it looks like. And to run it locally, all you have to do, if I can type straight, server.dart. That will turn around and start serving on localhost. But let's take it further. So back to presenting. I just showed you running on the local host. We can turn around and Dockerize. So we can turn around and build it using Docker and then run it. So actually, no, let's escape. I can't get out of my own browser window. So Docker build. So we can turn around and build this server. Now I have made a slight change to I've actually made a bunch of changes to the normal package. But one of the things that I need to add to the template is the stock standard Docker file that we have with Google Dart. Now, this one I'm, as you probably guessed, using null safe code, so I'm using the 212 beta branch. But apart from that, it's the stock standard Docker file. And here we've built things. And if I do Docker run and bind port 8080, we can see we're again serving at port 8080. And I can come over here and do localhost 8080 foo. And we get a request for foo. So this is all good and all, but how does this help us with going further? Well, let's talk about Cloud Run. What is Cloud Run? Cloud Run is a way of taking a Dockerized server application and running it in a little virtual server in the cloud. And what do we have to do? Well, we have to log in. So firstly, create yourself a Google account, create a project, then authorize your local command line using gcloud auth login. That will send you into a web browser where you can say, yes, please allow this command line to make changes to my project. Set your project. My one's going to be Bob's Burgers. We'll see this off in a bunch of different places. And finally, we can turn around and ask it to build. So I'll just, for various reasons, I need to actually run up a second shell to kill the Docker in the first shell. Now, what was that command again? gcloud builds. So what we're doing is we're submitting a build to a cloud build, and it's going to take a snapshot of the current directory, and we're going to tag it. GCR is the Google Container Runtime repositories, and Bob's Burgers is my project, and Dart server is the name of the actual thing that we're building. So I do that, and then I can drag in yet another window. And we can see, yes, here's all the tests I was doing while building this deck. We can see that we've kicked off a build. If we have a look in here, we'll see that this is streaming and matches pretty much identically here. So what we've got is we've pushed a bunch of code up to a server. That's now building in the server farm. And once that actually completes, we'll then be able to take that that image. Okay, it looks like it's completed. There we go. So we can now look at the container registry under Dart server. Remember, I pushed it to GCR, Bob's Burgers, Dart server, and this is the latest one. And what you can do, though I won't in this instance, is you can turn around and deploy to Cloud Run. This allows you to create a new endpoint, but to make sure the rest of my code works, I'm actually going to stick with a pre-built Cloud Run endpoint, just so that my DNS names all line up. So I can come over here and go to revisions and go edit and deploy a new revision. Let's just make this window a bit bigger. And as you can see here, again, this is that GCR URL that I pushed to originally to start building all of this. The container is expecting connection on port 8080. I'm giving myself some room to play with, 5-minute timeout, 80 requests, and importantly for those on a budget, it will actually support scaling to 0. This is different to, say, App Engine Flex, where you have to have a minimum number of machines serving to actually answer respond to requests. So we can turn around and kick off deploy, and this will then turn off and start taking that Docker image, instantiating a VM, and actually running some stuff. Anyway, back to our code. So talk through this, configure a project, push to it, and that actually creates your service that in the cloud. So having a service in the cloud is great and all, but it'd be nice to actually talk to it. And one of the downsides of all the various different APIs is you wind up having to build client libraries and all that sort of thing. So I'd like to introduce gRPC as a way of easily and quickly building APIs without the need to manually spin a wrapper for random JSON blobs. Okay, one of the things you need to do inside of Cloud Run is enable HTTP 2 connections, because gRPC relies on HTTP 2. This enables bidirectional streams, which we'll get to. This is something we released reasonably recently on Google Cloud. It also enables things like WebSockets. So for those of you living inside of web browsers, HTTP 2 isn't that easy to use, but WebSockets definitely are. So If you're looking to build real-time reactive websites, be it chat clients or whatever it is, something that actually interacts with the user, you can now use Google Cloud with Cloud Run to be able to empower those sorts of experiences. You just have to enable this preview connection style. Okay, so let's have a look at implementing different styles of APIs. So the first one we're going to start with is good old REST style. So let's drag in yet another window. Where is it? You'll notice they're all different colors. I do this so that I can remember which one's which. So let's just hide a few things. We'll come back to them later. Okay. So gRPC is a way of defining an API. So it starts off, you're looking at a protocol definition file. The syntax is Proto3. Yes, there were Proto2 and Proto1 back in the day. Many mistakes were made, many lessons were learned. Proto3 is the one that we suggest everyone uses these days. It contains a bunch of fixes for prior architectural misdecisions. Okay, so how do you start defining a protocol inside of gRPC? Well, the first thing you start with are messages. So in this case, what we're modeling is, for those of you who've used Flutter, you've seen the Flutter counter app. I'm going one step up and having multiple counters. So we're going to create an application that has the ability to create counters, add to those counters, decrement those counters, and if they decrement to 0, they go away. So this service effectively is a small part of, say, a Redis server where you have the ability to increment and decrement fields in memory. That's effectively what we're going to build. So the first thing we need is for this server to say, here's a counter, it's named foo, it has a count of 3. Okay, the next thing we need to be able to do is increment and decrement a named counter. Seems reasonable. And the last thing we want to do is turn around and when someone increments or decrements a counter, give them the list of the current set of counters and their current counts. So this is great. We've got a bunch of messages that go backwards and forwards, but I thought I was coming here to talk about APIs. Well, to talk about APIs, what we do is we create a service, and a service has an RPC. In this case, we have the ability to increment using the increment message, increment request, and we get the counters reply. And likewise, we've got the decrement request, and well, we should generate some code. So this is responsible for generating the client library. Remember earlier I was saying the upside of doing this is that we, slightly worrying. Yeah. Let's bring this back. And yeah, cool. So what we're going to do, I'm just going to reset a few things to make sure everything's sane. We're going to start taking this forward. So if we look in the directory, what we've done here is product dart out, and this gRPC project is beside the Dart server, which is this. And we've written in lib source generated for the counters. So we can see in here, lib source generated, and we've got these 4 files that are generated. They contain all of our client library information to be able to talk to the server or to create the server that we're going to build now. So let's go ahead and build. So first thing we're going to need is to include those files that we generated plus the gRPC support library. What we're going to do is counter service. This is going to be where we implement our business logic, i.e. we're going to have, well, let's just turn around and build it. Here's the counters. We have a name for a counter and the current count. Now, as I previously mentioned, there was the decrement call and there's an increment call. and some business logic. If we have the counter, then we increment it. If we don't have the counter, then we create it and set it to 1. Likewise, we have, we're going to return the list of counters in a counter object, the counters reply. And this is entertaining. It's currently warning us, saying it's not the right object type. How do we get around this? Well, we mark this whole function as async, and because it takes a future of counters reply. This is not necessary for us right now, but what it comes back to is the fact that you kind of expect when you make a call to an RPC service that it might need to read to disk, it might need to talk to some other servers, and it will come back to you at some point in the future. And in Dart, that's all modeled, thankfully, through futures and streams. So let's start implementing decrement. Likewise, we've got business logic, and we have the return. And what does the actual main server look like? Well, strangely enough, once my editor finishes typing, there's not that much here. We create a server that has the service. We're handling gzip codec and identity codec. And finally, we serve on port 8080. Cool. Let's turn around and push this all. Oh, yeah. Just to confirm, I'm just cleaning up the imports. And here's the command to actually turn around and, as previously, push this all up to Google Cloud. Now that's going to start building. I'm going to let that build because having a server in the cloud doing something is nice and all, but it's much nicer if we can actually look at that code and, use a client library to do something with it. So to turn around and actually build something, let's do the same generation, but actually push it into a Flutter client. So likewise to the Dart server that I was just showing you, I've got another project alongside this one called Flutter client. And let's drag that in. So yes, the sort of grayish one, this one is the gRPC, the red one is the server, the blue one is the client. Now, there's a fair amount of code here, but it's basically a slight adaptation of the Flutter counters application. So I'm not going to go through explaining it very much, but the only thing of note that I'm really going to concentrate on is this change notifier, which I'm using provider to turn around and provide into the rest of the application. Could actually run this right now. So let's bring this up. Let's just build for Mac OS. And no, I don't want to enable. Okay. So debug console. So we're launching this on a Mac OS in debug mode. This will take 30 seconds or so, hopefully. And in the meantime, I can see what, oh, that's finished building. The only downside of being a developer is you have to develop multiple things at once. So let's edit and deploy a new revision. Take that off screen. And previously I mentioned that to use gRPC, you need to enable HTTP to connections. So we've done that. Let's deploy the latest version, which is the one we just pushed here. Okay, that's going to give us a gRPC server. Here's the multi-counter app. The idea being we can enter a counter and go create the counter, but, well, it doesn't do anything because, well, nothing's implemented yet. So let's fix that. So the first thing we're going to do is pull in gRPC and the client libraries. and let's start implementing. So for those of you who are using the current stable version, this magical late keyword might look a bit interesting. It's actually an addition to the null safe version of Dart, which you will all be seeing a whole bunch about really soon now. I'm effectively just living in the future a bit to show off that, interesting new things are happening. Okay, so we've got this counters client. Let's build a constructor. This DNS name, if we have a look in here, we can actually see that DNS name here. So I'm talking directly to the gRPC service in the cloud. I'm using channel credentials secure. The Cloud Run is supplying us a SSL certificate, and we've got a client. Now let's actually turn around and build out the ability to send those messages that I was talking about, gRPC messages. So that sends the increment and decrement message, but we should also deal with the response that comes back with a list of counters. And what we're going to do is create this function, and it's going to clear the counters, go through each of the counters in that response message, and set them in the local state, which is up here, and then notify listeners, which is the change notifier protocol, which will then turn around and call set state under the hood to update our Flutter screens. Okay, let's wrap both of these awaited requests so that we can handle the response, and that should be it. So I can now bring some additional players to bear, and I can turn around and not just run one. I can make my laptop really unhappy by trying to run all three. So as you can see, I'm now compiling up Android, iPhone, and Mac OS. And it's usually not this cramped, but I'm running at a reasonably high or a reasonably large font size to make this legible on fonts on YouTube. So let's see if I can get the debug console, and we can see that we're building out iPhone 8. Mac OS is also, that's building, and Android is also building. So just waiting 30 seconds for the world to build. Let's go back here and make sure, yep, we've got the latest one that's serving. We can have a look in our logs and make sure that we've actually got something here. You can actually see debugging traffic from when I was previously using it. The important line here is the server is listening. It was replaced. Okay. Let's hide some of the noise. So the macOS desktop application has come up. The iOS one has come up, and Android has coming up in the process thereof. Okay, counter name. So I should be able to do hello. Come on. There we go. Flutter. And about now, you should be going, there's something very wrong. And it's about now that I go, that's interesting. That doesn't look right. I've got hello Flutter developers. And if I was to add something else over here, what's going on? Why am I getting this sort of differentiated understanding of state on the server on my three screens? And about now, firstly, I'll shut down a bunch of things. Let's hide that. And I'll come back here and remind you that the RPCs as initially defined was you send an increment or decrement request, and then you get a copy of the state as it is at that point in time. Interesting. This is actually how most APIs work. You basically ping them, they tell you what the current state is, but they don't promise to give you any update of the future. And that's kind of a problem. And that's the traditional problem with a lot of APIs. So, oh yeah, here's my slide giving it away. So what we've just implemented is a REST style. The next one I'm going to show you is the streaming response. And if we have time, I'll show you bidirectional. So let's go ahead and refactor things so that we don't have the problem we were just seeing. Okay. So what do we have to do? What changes do we have to make to actually have state updated on the clients in real time or semi-real time? Well, the first thing we need to do is introduce some new concepts. So I'm going to have a counter request and counters reply, and I'm going to have a null reply. Now, in gRPC, all RPCs have a request and response object. There are ways of saying that this has no actual response as opposed to just this null reply. One of the patterns that I've seen is that you really want to have a named request and response object to every RPC, because at some point you'll want to add something new to either the request or the response. And if you have to change the name of your object, that's a backwards breaking change. Whereas if you have an object and you're just adding attributes to it, that's not backwards breaking. So done that. What we're going to do is introduce a new endpoint service. And the important thing is this keyword here, stream. So what's going to happen is someone's going to connect to the service. They're going to give it counters request, which is currently an empty object, and they're going to get a streaming response. So this is traditionally what people normally do when they first play with something like WebSockets. They basically want to be able to connect to a status thing that tells them, new messages have arrived, or update your screen because of whatever, and so on and so forth. So this is effectively the start of a streaming reply service. Okay, what just happened? Oh yes, because increment and decrement don't need to respond with anything, because all the status change information is coming over this service request. We can turn around and do that. Okay, time to generate some new API client libraries. So let's do that again. Let's do the server. So somewhere here, I've got a red editor. And as you can see, suddenly everything is upset because I've changed the type of things. So let's hide that window and go forward. A lot happened just there. So the first thing is we drop the this tag, which is mainly there to remind me to type it. But the more important thing is we're no longer responding to the decrement call with anything. We're just returning an empty null reply. Let's do the same for increment. And finally, we need to implement this service that's actually going to be responsible for generating to updating all the clients to tell them the world has changed. I'm now going to lean on a package called RxDart. RxDart is really neat. It gives us a way to create a stream really effortlessly that we can then turn around and put messages into and have the stream go out. So the class in question is called behavior subject. In this case, it's the behavior subject of counters reply. So what we're going to do is we're going to take that subject, take the stream of it, and that becomes the response to listening to a service. And then we're going to add to both increment and decrement is this chunk of code that turns around and constructs the counters reply as it did before, but it turns around and adds it to the subject. This is how we effectively broadcast it to everyone. there's exactly one subject for the server. Everyone who calls increment or decrement then updates the state in subject, and then that gets passed out to everyone who's currently listening to the service stream. So behavior subject is acting as a broadcast stream. Okay, it's telling me to build again, so let's bring that up. Start building again. And back over here, we go to the next page. Let's update the Flutter side of things. So we've changed the client library. We go to the Flutter window. Remember, Flutter is the blue window. Server side is the red side because it's dangerous. Okay. As you can see, because we've changed the contract of the API, the client library has turned around and broken our code. This is the nice thing about automatically generated client libraries, is that you get type safety. So let's turn around and start making some changes. What did we change? Oh, we deleted that line that told me to do things. Next thing we're going to do, just to show you again, we're removing update counters because increment now doesn't, it returns the null reply, doesn't give us any useful information, which means that update counters are sitting here all lonely. So what we're going to do is we're going to make a call to the service, and then listen basically handles that stream response and uses update counters. And that's the entirety of the change. That's actually finished building. So I need to go back to the cloud run, go to the Dart server, go to revisions. Yep, edit and deploy a new version. Deploy. And that will take a couple of seconds, during which time I'll dig out my phones. Yep, that's deployed. So I can come back here to Flutter, go all devices, start, and this will take 30 seconds or so to spin up and bring up all the devices. We've got code, we've got the server running. This is the RPC we've got running. This time, when I turn around and come on, wake up. What's going wrong? I don't know. Everything's broken. Let's go have a look in the logs. Increments are going through. Don't know. The joys of debugging live applications. Yeah. So, don't quite know why this is broken. That's hilarious. It worked previously. But as German has just pointed out, I'm out of time. So I'm curious if there are questions. And if there aren't, then I'll show the most important slide in my slide deck. So I didn't get to bidirectional. As I hope most of you know, it's probably March 4th for all of you, but really soon we're going to be doing our quarterly release the new version of Flutter. We encourage you all to come along and see what we're announcing. And with that, thank you.